Good morning, everyone. Welcome to Guru Brahma classes for JEE and NEET. Today in this session, I am going to teach you about different nomenclatures used in optical isomerism. Let us start the session. You can see here nomenclature used in optical isomerism. One is D and L nomenclature. This is capital D and capital L. It is not small d and small l. Small d and small l has a different meaning. Small d has a meaning dextro. Small d can also be represented in another form is plus. Okay, if a compound rotates the plane of the polarized light in clockwise direction, then we say that it is dextro. Okay, so small d has a different meaning. It is dextro compound. Small d means dextro compound. Small l, if a compound rotates the plane of the polarized light in anti-clockwise direction, then such compound is called as LIGO compound. So small d and capital D are not same, they have a different meaning. So you have to be very careful while using the small d and capital D, right? You should know the differences between the small d and capital D, small l and capital L. Another nomenclature is R and S nomenclature. In the examinations, we find more questions on R and S nomenclature. By using this R and S nomenclature, we solve questions from the previous entrance examination. So both the nomenclatures are important, both are to be understood, right? Let us first go with the D and L nomenclature. What does this D and L nomenclature represents? D and L nomenclature is mainly given to sugars and amino acids. So D and L nomenclature is mainly given to carbohydrates, monosaccharides and amino acids mainly. So D and L nomenclature is only used for chiral carbon. For which carbon do you use D and L nomenclature? If the carbon is chiral, at that carbon atom, at that particular carbon atom, what is meant by chiral carbon atom? You know, the carbon to which 4 different groups are attached is called as chiral carbon. Okay. And only at that chiral carbon atom, which is also called as stereo center, we use this D and L nomenclature. Not only D and L nomenclature we use at stereo center, R and S nomenclature is also used at stereo center. What is that? Chiral center especially. What is that? Chiral center. Here you can write D and L, R and S configurations or nomenclature is used or written at chiral center. Chiral center, which is an example of stereo center. We know that chiral center is an example of what? Stereo center, right? Next, let us see this. Where do we use D and L? If last but one carbon has OH on the right hand side, then it is D molecule, and if it is on the left hand side, then it is L molecule. Last but one carbon atom. Let us see here, it is glyceraldehyde. What is the name of this? Glyceraldehyde. I am mentioning it as D-glyceraldehyde. That means here, when you number this compound, numbering for the purpose of naming a UPS name, we number the parent chain, right? In numbering the parent chain, we select the parent chain containing functional group. Here functional groups are there. What functional group? One is aldehyde, another is alcohol. So aldehyde will have more priority. So 1, 2, 3. What is the last carbon atom? Third carbon atom is the last carbon atom. Last but one carbon atom is second carbon atom. And this carbon atom at the center, at the cross, this is what representation? It is what representation? Fisher representation. Fisher representation of the molecule. So in Fisher representation, how do we represent a molecule? We represent a molecule in the form of cross, that is vertical lines and horizontal lines. Wherever this vertical line and horizontal line meet, there will be a carbon atom. What is present? Here you have one carbon atom. So this carbon atom is attached to 4 different groups. One group is OH, one group is H, one group is CHO, and another group is CH2OH. Are you finding this? Now I can say that this carbon is chiral carbon, right? This carbon is chiral carbon. Whenever it is chiral carbon, we represent it by a asterisk sign, star. Okay. So at this carbon atom, and this is last but one carbon atom, we are writing D and L for this carbon atom. What you are finding? OH is present on the right side. OH is present on right side. When OH is present on right side, what do we use? We use D. That is just meaning for capital D. For capital D, what is the meaning is last but one carbon which is chiral, at this chiral carbon, OH should be present on the right side. That represents a capital D molecule. Here what do you find? You find OH on the left side. Okay, OH on the left side in this molecule. What will be this? This is also glyceraldehyde. This is also glyceraldehyde, but it is L-glyceraldehyde. Why? Already it was mentioned that if OH is present on the left side, then the nomenclature given to that compound is L. Are you getting this? Simple thing. OH on the right side, D compound, OH on the left side, L compound. So this is glucose actually. What is that? Glucose. We are only looking the last but one carbon atom. Okay. So here 1, when you number this, 1, 2, 3, 4, 5, 6. Because aldehyde functional group, numbering starts from aldehyde functional group, aldehyde carbon atom. Because only 2 functional groups are there in this compound. One is aldehyde functional group, another is OH functional group. Among aldehyde and OH, aldehyde and alcohol, which has more priority? Aldehyde has more priority. So you are numbering from that carbon atom. Last but one carbon atom will be the 5th carbon atom. See. And this 5th carbon atom, if you see, it is chiral because 4 different groups are attached to this. One is OH, one is CH2OH, another is H, another is this complete group. As 4 different groups are attached to this carbon atom, I represent it as asterisk sign. What does that represent? Asterisk sign represents that the carbon is chiral carbon. And that is also chiral center, which is an example of stereo center. Now, where is OH? OH is present on the right side. So, what I can write? It is D-glucose. Simply, last but one carbon atom, OH on the right side, that is D compound. Last but one carbon atom, 1, 2, 3, 4, 5, 6. Last but one carbon atom, this is last but one carbon atom, where OH is on the left side. And this is glucose molecule. I write it as L-glucose. So based on the OH present on which side at the last but one chiral carbon, D and L nomenclature is used. Understood? Next, coming to in the case of amino acids, what is that? In the case of amino acids, if NH2 is present on the right hand side, then it is D molecule, and if NH2 is present on the left hand side, then it is L molecule. Simple thing. Okay. Where is NH2 present here? This is amino acid. What amino acid? Alanine. What is this? Alanine. Where is NH2? NH2 is present on the right side. So it is D-alanine. If you want to differentiate into D-alanine and L-alanine, you can differentiate in this way. Okay. Where is NH2 here in this molecule? NH2 is on the left side. So I can write it as L-alanine. Okay. So that is D and L nomenclature, very simple one. And here also it is last but one carbon atom. Here you see it starts from here 1, 2, 3, and this carbon atom is chiral because COOH functional group has more priority. And to this carbon atom, 4 different groups are attached. One is CH3, one NH2, COOH, so it is chiral again. Here also it is chiral. 1, 2, 3. Last but one carbon atom. Understood? Okay. So that is simple. D and L nomenclature is very simple. In amino acids, if NH2 is present on the right side, then that is D. NH2 is present on the left side in the last but one carbon atom, that is L amino acid. Understood? Simple thing. Next, R and S nomenclature. We are speaking about the R and S nomenclature of asymmetric carbon atoms. Not only asymmetric, only carbon atom. Do you feel that carbon atom is only asymmetric? There are other atoms which can also be asymmetric. What is meant by asymmetric here? Here it represents that if carbon atom is attached to 4 different groups, then that will be asymmetric carbon atom. For example, let me take here carbon. So it is attached to COOH, it is attached to CH3, it is attached to H, and it is attached to OH. Now what about this carbon atom, central carbon atom? This is attached to 4 different groups. So I can say that it is asymmetric carbon atom. Asymmetric carbon atom. So for this asymmetric carbon atom, we write R and S. For whom we write? For this asymmetric carbon atom, we write R and S nomenclature. If the carbon is not asymmetric, if it is not bonded to 4 different groups, then we don't write R and S nomenclature. Already we have discussed D and L nomenclature or R and S nomenclature. Both are written for the asymmetric atom, the atom which is bonded to 4 different groups. So not only carbon atom will be asymmetric, there can also be nitrogen. See, nitrogen plus, what is this? CH2, CH2, CH3. Let us take it as H. What is this? CH3. Then what is this? CH2, CH3. Now nitrogen is also bonded to 4 different groups. Is nitrogen bonded to 4 different groups? Yes. As nitrogen is bonded to 4 different groups, I can consider this nitrogen as asymmetric atom, chiral atom. Okay. So not only carbons, there are other atoms also to which 4 different groups are attached. So the atom to which 4 different groups are attached will be called as what? Asymmetric atom. So for that asymmetric atom, we are writing this R and S nomenclature. Understood? Right? So how to write R and S nomenclature? There is some procedure. That procedure we shall see. The Kahn-Ingold Prilog convention is most widely accepted system for naming the configuration of chirality centers. So, in naming R&S for the chiral center, what rule is followed? What convention is followed? What is that? Kahn, Ingold and Krylov. These three scientists combinedly gave some rules to decide the priority. Based on those rules and based on those priority, we name R&S. Okay. So in these two steps are followed in naming. Two steps are involved. One step is assign a relative priority to each group bonded to the asymmetric carbon. This is done according to SIP rules. They have proposed some rules. Who? Kahn, Ingold and Krylov scientists. See, now there are 4 different groups. For these 4 different groups, like let us take this one, lactic acid. What is this molecule? Lactic acid. So this lactic acid molecule contains 4 different groups and we can give priority based on SIP rules. Based on SIP rules, we have to give priority. Priority means priority 1, 2, 3, 4. Priority 1 means high priority. Priority 4 means least priority. Okay. So, what you are doing for the 4 different groups attached to chiral atom, priorities. What is that? You know what is meant priority? Priorities, preferences. Priorities are assigned according to SIP rules. According to SIP rules. These SIP rules already we have discussed in geometrical isomerism. One cycle while solving problem we will be coming across through. Okay. So priority 1 means first priority, high priority. High, what is that? High priority. That means priority number 1, priority 2, priority 3, then we will go with priority 4. What does 4 represent? Priority 4 means least priority. So priority 4 means least priority, priority 1 means high priority or highest priority. Understood? So in this way, the 4 different groups are given priorities based on SIP rules. Next, put the 4th priority group away from the plane and draw an arrow from the first priority group through the second and to the third. What you need to do now? You have to keep the 4th priority away from the observer. Away from the observer or out of the plane or away from the plane. So let us see what is away from the plane or what is in the plane. C, COOH, here CH3. This single line, the single lines or simple lines represents they are in the same plane. I can write this what COOH and COOH, C also, carbon and CH3 are in the same plane. Let us consider this as paper. On the paper, COOH and CH3 are present in the same plane, XY plane. Let us take this. What board you are seeing, this white board, what you are seeing is XY plane, in the same plane. Now let us go with this OH. This is called as wedge. Okay. If it is represented in this way, where is OH? This OH is towards the observer. Towards, now I am observing. Towards observer. Or I can say it as above the plane. Now only we have considered this whiteboard as XY plane, above the plane. That means towards observer. Now if I am mentioning that this broken line or dotted line, I can mention it as a dotted line. This dotted line represents that it is away from the observer. Away from observer. Or we can mention it as below the plane. Below the plane. Understood? Now, hydrogen anyway, its atomic number is 1. So it has least priority. So what priority it is having? Fourth priority. 4 priority. Now it is away from the observer. Are you getting what is the meaning of that? If you see, put the fourth priority group away from the plane. Is the fourth priority group away from the plane? Yes. Hydrogen has least priority. According to SIP rules, how priorities are given? This is chiral carbon. The atoms attached to chiral carbon, atomic number is counted. Atomic number is counted. And based on the atomic number, the one which is having least atomic number is considered to be having least priority. See, hydrogen is having atomic number 1, so it will have least priority. So now we have made this hydrogen, or we are finding this hydrogen away from the observer. Are you finding a hydrogen away from the observer? Yes. Now, after making this least priority group away from the observer, then you have to rotate. Now let us see. Here it is having highest priority. OH is having priority 1. COOH is having priority 2. And carbon, this is having priority 3. Now, what you are doing? Looking at these priorities, we have to draw an arrow. Draw an arrow. See, draw an arrow from the first priority group through the second and to the third. Where is first priority? Here it is first priority. Right? Here it is a first priority. From first priority, I'm drawing an arrow in this way. Drawing arrow up to from first to second, and after you are reaching 3. You have to move this arrow from first priority group to the third priority group through second priority. So how you second priority is assigned, how third priority is assigned, we will understand. We will discuss. Actually, already it is discussed in geometrical isomerism. Again, we will discuss while solving the problems. Okay. So here the meaning is, if the arrow points clockwise, is this clockwise or anti-clockwise? Actually, it is anti-clockwise. What you are seeing? If the arrow points clockwise, then the asymmetric carbon atom is named as R. That means if you get an arrow like this, clockwise, in this way clockwise, first group 2 through second up to 3. Then if you get clockwise, it is R. You are finding anti-clockwise there. If it is anti-clockwise, right, like this. If it is anti-clockwise, arrow is like this. From first to third group through second group, then it will be S. So from first to high priority group to third priority group, if you are drawing an arrow, if you find that it is clockwise, then we have to name it as R. It is extracted from Latin name rectus, means upright. If the arrow points counterclockwise means anti-clockwise, then the chiral carbon is named as S. S means sinister. From Latin word sinister means left. From there it has been derived. So if you find a clockwise arrow, when you are moving from first priority group to third priority group, this is all when the least priority group is away from the observer. If you find it is clockwise direction, then you have to name it as R. Which one? Chiral carbon. For chiral carbon, we are naming this R and S nomenclature. If you find it anti-clockwise, then you have to name it as S. Understood? Let us move to the next. So now we are representing here flying wedge representation. Flying wedge representation. In this flying wedge representation, what you are finding, you see this carbon atom is attached to 4 other groups. One is hydrogen, COOH, CH3, NH2. Okay. So now let us see C double bond O. Okay, OH. This is what H, nitrogen, H. This is CH3. And detailed structural formula I have written here. Okay, structural formula I have written. So here you are finding NH2 towards the observer, H away from the observer. Now you have to write the priority. How to decide the priority? This is chiral carbon. So first we have to, what is that? First we have to see the atoms directly attached to the chiral carbon. Directly attached to chiral carbon, if you see, here you are finding, see, carbon same. First direct atom attached to the chiral carbon. Here you are finding hydrogen. Here you are finding nitrogen. So nitrogen atomic number is COOH. Because here actually C double bond OH, pi bond is converted into hypothetical sigma bond. Actually what you have C double bond OH. C double bond OH. In the case of when multiple bond is present, what you have to do? You have to break this pi bond and you have to convert it into hypothetical sigma bond. Hypothetical means imaginary. You have to consider it imaginary. Okay. So let us try to understand it very clear. See, this is chiral carbon, directly attached carbon atom. This group we have taken, COOH group. Next, chiral carbon CH, chiral carbon CH, chiral carbon NH. All those 4 groups attached to the chiral carbon I have written clearly. Now see, directly attached atoms, if you see, nitrogen has atomic number 14, carbon has atomic number 6, carbon has atomic number 6. Okay, here it is not correct. Here directly what is attached? Hydrogen is attached. Hydrogen has 1, carbon has 6 atomic number. Nitrogen has atomic number what? 7. So first rule, what is that first rule? We have to check the atomic numbers of the atoms which are directly attached to the chiral carbon. So which has highest atomic number? Nitrogen has highest atomic number. So what you have to do? You have to give priority 1 to NH2. More the atomic number of the atom directly attached to the carbon, more its priority. So priority 1 is given to NH3. And hydrogen has least atomic number, so 4 is given to hydrogen, least priority. When you are going with priorities of these two groups, one is COOH, carboxylic acid group, another is methyl group. Directly attached atom is same. This is carbon, this is also carbon. Then what you have to do? When directly attached atom to the chiral carbon are same, then you have to see the next atom. What do you need to do? You have to see the next atom. You have to go with the next atom. You have to see the point of difference. If you see the next atoms in COOH group, you have oxygen atomic number 8. Here you have only hydrogen atomic number 1. So the same rule is followed. What is the first rule? The first rule is that more the atomic number, more the priority. If directly attached atoms are same, then you have to move to the next atoms and you have to follow the same rule of high priority for high atomic number. So now here you have atomic number 8 for oxygen, you have atomic number 1 for hydrogen. So which has more priority among COOH and CH3? COOH will have more priority, priority number 2. And automatically CH3 will have priority number 3. Now rotate, now assign here priority number 1, priority number 2, priority number 3, and hydrogen has least priority. And least priority number 4, that is least priority group. And this least priority group is away from the observer. Away from the plane. This is what rule said. First of all, you have to see that the least priority group is away from the plane and you have to rotate the priorities. When you rotate the rotating means you are drawing an arrow. When you draw an arrow from priority number 1 to priority number 3, what you find? You find an anti-clockwise direction arrow. What you are finding? Anti-clockwise direction arrow. If you find anti-clockwise direction arrow, then whether it is R nomenclature or S nomenclature, it will be S compound. It will be S compound. So we are assigning R or S for the given compounds. This is S. Let us see the next question. Next one. Now coming to this. Is the central carbon atom chiral or not? Yes, it is chiral because it is attached to 4 different groups. Now let us see here. C star, that is chiral, is attached to, first group is CH2. This is CH2 Br. The second one, star is attached to hydrogen. C star is attached to bromine. C star is attached to CH3. And we know that bromine atomic, see, carbon 6, hydrogen 1, bromine 35, okay, and the carbon is 6. Now you say which has high atomic number? Which has high atomic number? Bromine has high atomic number. So priority number 1. Next, least priority hydrogen. Hydrogen least priority. Priority number 4. More the atomic number, more the priority. So directly attached atoms, if you see, in the case of CH2, CH2Br and CH3, now directly attached atoms are same. This carbon atom is same and this carbon atom is same. Now only we have discussed that if the directly attached atom is same, then we have to see the next atom. When you see the next atom, what you are finding? Here you are finding what? Hydrogen, hydrogen, carbon. Whereas here these three are hydrogens. Two hydrogens let us cancel. Two hydrogens let us cancel. The other one is carbon. Here the other one is hydrogen. So among CH2, CH2Br and CH3, which should have more priority? Which should have more priority? This must have more priority, second priority, and the third priority is to be given this. Understood? Okay. Next, now rotate, now draw an arrow from first priority group to third priority group. When you draw an arrow from first priority group to third priority group through second priority group, what do you find? You find a R. What you are finding? Clockwise arrow. If you find clockwise arrow, keeping the least priority group away from the observer or away from the plane, then what is that molecule? R molecule. What is that? That is a R molecule. Okay. So let us move to the next one. Here again, this is C star. Okay. So C star is attached to whom? C double bond O, OH. What did I say? If there is multiple bond, what you need to do? You have to break the pi bond and convert into hypothetical sigma bond. Hypothetical sigma bond. Right? Next, C star is attached to hydrogen. C star is attached to OH. C star is attached to CH3. Okay. Let us see the first attached atoms. First attached atoms has atomic number here 6, here 1, here 8, here 6. Okay. Now which has high atomic number? Directly attached atom of OH. OH is having highest atomic number, so priority number 1 is given to OH, and least atomic number hydrogen, least priority 4. So what do you see? Least priority. So anyway, least priority is away from the plane. What does this dotted lines represent? This dotted line represents that the molecule is away from the plane. Now among COOH and CH3, which has more priority? Directly attached atoms are same. Carbon, carbon. What is that? Directly attached atoms are same. If directly attached atoms are same, then what you need to do? You have to move to the next atom. Let us move to the next atom. Here you have oxygen, atomic number 8. Here you have hydrogen, atomic number 1. So whose atomic number is more? Oxygen's atomic number is more. So COOH group will have more priority than CH3. So second priority will be COOH and the third priority will be CH3. Now rotate from first priority to third priority groups. That means when you draw an arrow, what arrow do you are finding? Clockwise direction arrow. What is that? Clockwise direction arrow. So this clockwise direction arrow represents that the group, the molecule is R molecule. For whom you write this R and S? We write it for this chiral carbon. Right? Let us move to the next one. Coming to the next molecule, you see, in all these three molecules, up to now what the molecules we have seen, all these three molecules, hydrogen is away from the observer. But here if you see, hydrogen is above the plane, that is towards the observer. That means least priority group is towards the observer. So now let us see what you need to do. This is chiral carbon. Okay, chiral carbon. This is chiral. So this chiral carbon is attached to whom? CH3, right? This chiral carbon is attached to whom? CH, CH3. This chiral carbon is attached to OH. This chiral carbon is attached to hydrogen. So go with the atomic numbers. Directly attached atoms 6, 6, 8, 1. So least priority again is hydrogen. So priorities, if you take what, fourth priority and first priority, because atomic number is 8. When among CH2, CH3 and CH3, which has more priority, directly attached atom is same here. Directly attached atom is same here. Then next to hydrogen, hydrogen, hydrogen. But here hydrogen, hydrogen, carbon. So if directly attached atoms are same, then what you need to do? You have to move to the next atom and follow the same rule of high atomic number. Here atomic number of carbon is 6. So this will have high priority than CH3. CH2, CH3 is having a priority of 2 and this is having a priority of 3. Okay. But now this hydrogen is not away from the plane. It is in the plane. It is above the plane. So least priority group here is where? Least priority group is above the plane. What did we learn? It has to be away from the plane. In one way, what you can understand is, first of all, let us draw an arrow from 1 to 3 priorities. 1, 2, 3 priority. What you are finding anti-clockwise? So you are finding yes. Okay. You are finding this arrow and it's moving anti-clockwise. So you have to give, actually you have to give what it as S molecule. But as least priority group is above the plane, what you observe, you have to write opposite to that. You have to write opposite to that. So you can state it. When least priority group is above the plane, when least priority group is above the plane or towards the observer, the molecule is named opposite to the observed. If S is observed, R is written. If R is observed, S is written. This is one way. This is what? One way. So now what you are observing? Yes, you are observing anti-clockwise. So this molecule will be what? R. This molecule is R. Or otherwise you can do another thing. You can shift. Let us see shift. Now OH is shifted with H. Why? Because where is least priority group? Least priority group is above the plane. So you have to make it into below the plane. So what you are doing? You are shifting this H and OH. So what is done? Positions are shifted. What is done? Positions are shifted. Now we are happy because least priority group is away from the observer. Now when you are shifting these two, shifting is nothing but you are rotating the molecule. What you are doing? You are rotating the molecule. When you are rotating the molecule, what do you find? When these two positions are shifted, are changed, when H and OH positions are changed, automatically CH2, CH3 and CH3 positions will also change. Automatically, you can rotate the molecule and you can find automatically when two positions are changed, then automatically other two positions also get changed. Now assign the priorities to this. If you assign the priorities 1, 2, 3, least priority is away from the observer. This is very simple actually. If you shift the molecule or if you change the positions, then it will be very easy. Now draw an arrow. 1, 2, 3. What you are finding? R you are finding, and H is away from the observer. So least priority group away from the observer, and when you draw an arrow, you are finding clockwise. So R, directly R. Either you can follow this, or you can change the positions and find the answer. It's very easy now, right? Here most of the people get confused. It's very clear now. Now you see, this is also a situation we have to shift. So priority, directly I am writing priority 1, priority 2, priority 3, priority 4. Where is this molecule actually? Where is this least priority group? Least priority group is not in the away from the plane. It is not away from the plane, not below the plane. Okay. So it is in the plane. Now you have to shift in this way, shift these two. What you are doing, change the positions of these two. Bromine comes here, hydrogen comes here. Automatically CH2, CH3 comes here, CH3 comes here. Change the positions. When you change the positions, change the position. Why we are changing the position? We are changing the position to see that the least priority group is away from the plane. So C, now what happens? Bromine, hydrogen, CH2, CH3, CH. Right, simple. How simple it is, you see. Now what you are doing? Priorities 1, 2, 3, 4. 4 is away from the observer, away below the plane. So least priority group is below the plane. Now whatever you observe, you can write the answer. So 1 is here. 1, 2, 3. What you are observing? Counterclockwise. Counterclockwise. So what is this molecule? This is R molecule. Sorry. This is what? Counterclockwise now? S molecule. What is this molecule? S molecule. Understood? So here most of the people get confused. Next, what is the chiral carbon here? This will be the chiral carbon. Let us see that chiral carbon is attached to CHO. CHO means C double bond O H. What you have to do? Already it is mentioned that if there is double bond, you have to convert pi bond into hypothetical sigma bond. Sir, after O, what should be there? The members get confused. After O, actually O is attached to whom? Carbon. So after O, who will be there? Again carbon. After O, who will be there? Again carbon. Are you getting this? See, oxygen is attached to whom? Oxygen is attached to carbon. Sir, after writing O, if you want to decide, then what is there after O? Actually, to whom O is attached? Carbon. So after O again you will have carbon. That's the meaning. Okay. So let us see that. Next, C star, that is chiral carbon, is attached to CH double bond CH2. What I have said, what is said, this pi bond is to be broken and converted into hypothetical sigma bonds. C double bond C now. Again here comes C, here comes C. Okay. So let us make it big so that there will not be any confusion. C star, here C double bond C. Okay. H2. This is the situation. Now what you have done is you have broken this pi bond and converted into hypothetical sigma bonds. Actually, this pi bond is between carbon and carbon. So again, you get C and C here. Are you getting this? Right? So let us see. Again, C star is attached to whom? C star is attached to CH, CH3, CH3. Next, C star is attached to whom? CH. Okay, OCH3, OCH3. Right? Now, here it is somewhat typical to understand. Let us see here. Directly attached atom is first directly attached atom. First atom which is directly attached to chiral carbon. This one, this one, this one, one. All are carbons only. All are what? Carbons. Okay. All are carbons. Next atom, let us see the next atom. Next atom, let us oxygen, oxygen, hydrogen. Here next atom is carbon, hydrogen, carbon. Here next atom is carbon, carbon, hydrogen. Here next atom is oxygen, oxygen, hydrogen. Okay. So if you see this, this one and this one, after carbon, two oxygens are there. After carbon, who is there? Oxygens are there. But which is very much similar in both. Very much similar in both. Now, if you see here, this CH3, what do you write? CH, H, H, and H, H, H. After this C, who will be there? Next atoms, let us find the next atoms. Next atom is carbon, carbon. Here also carbon, carbon. Okay, anyway, hydrogen, common. Next atom, what will be the next atom? The next atom will be actually oxygen, oxygen. Because carbon is attached to oxygen, no? Here oxygen, oxygen. Here what is present? Here what is present? Hydrogen. Okay, hydrogen. So who will have first priority? This will have first priority, high priority, priority number 1. Okay, next priority is here you will have next priority, priority number 2. This have priority number 1, priority number 2. Next, among these two, let us see. First attached atom is carbon. The next attached atom, carbon, carbon, hydrogen, carbon, carbon, hydrogen. But what about here? Here the difference arises. Here the difference arises. See, here you are writing CH3. C, H, H, H. Here H, H, H. Right? Where did the difference arise? In this point, the difference has arisen. So which will have more priority? This will have priority number 3. This will have least priority. So least priority group is this. Least priority. So least priority is away from the plane. That is above the plane or below the plane? Above the plane. Where is it? Where is it? Above plane. So if it is above the plane, what you are finding? Let us rotate. What you are finding? You are finding a clockwise arrow. But least priority away from the plane or towards the plane, above the plane or below the plane. It is above the plane. It should be below the plane. It should be below the plane. As it is above the plane, what arrow you are finding? To that opposite you have to write. What will be the opposite? You are finding R. The opposite is S. So the molecule is S. The molecule is the S. Or otherwise, change the positions. If you change the position, if you make this least priority group to move to below the plane, then what you get? C, CHO. See, you are changing the positions. Change the position of first of all 3 and 4. If you change the position of 3 and 4, what do you get? Here you get CH, CH3 taken twice, least priority, and here you will have CH double bond CH2. Change those positions, CH, OCH3 taken twice, and here it will be CHO. Now write the priorities 1, 2, okay. So before we have written it is wrong. Arrow properly we did not mention. Here it is 1, right? Now what do you get? What do you observe? This is 1, 2, 3. What you are finding? You are finding yes. But as least priority group is above the plane, it will be R. Now you see 1, 2, 3. 1, 2. This is the third priority. 1, 2, 3. Okay. So now this will be R because you are finding clockwise and the least priority group is away from the observer. Where is the least priority group? It is below the plane. This is below the fourth priority group is below the plane. So what you observe, you can write. So directly you can say that if least priority group is above the plane, what you observe, you have to write opposite to that. Or if you exchange the positions, it will be very clear. Understood? Okay. So let us move to the next one. Up to now you understood. I am directly giving priorities, right? So this is chiral. This is chiral. I am giving priority 1. After C you have double bond O, right? So 2 I am giving it as a third priority. Third priority group is this group. So let me rotate. If you draw an arrow, what you find? You find R. Okay. And H is away from the observer, that is below the plane. So what will be this? R at this carbon atom. What about this carbon atom? Third priority. OH first priority, COOH second priority. This total group will be third priority. Now here 1, 2, 3. Okay, rotate. That means draw an arrow. You are finding anti-clockwise. This is clockwise. And H is away from the observer. Here H is not below the plane. H is above the plane. So what you observe, you have to write opposite to that. What you are observing? You are observing yes. So it will be R. So at both carbons you have R configuration or R naming. So first of all, the main thing which decides here is finding the priority based on SIP rules. You have to find which group has high priority, which group has a low priority. That is the basic thing. Next, let us move to the next part. Now you are finding here Fisher representation. What is that? Already it is mentioned about Fisher representation of the molecules. Fisher representation of the molecule. In this Fisher representation, you can see vertical line. So this is vertical line and this is horizontal line. Okay, so the molecule is represented in the form of a cross where there is vertical line and where there is horizontal line. In the vertical line, we can say that the molecule is away or below the plane. At the center there is carbon atom. Okay, vertical represents that the molecule is below the plane. Below the groups which are present in the vertical line are below the plane, and the groups which are present above the plane. Okay, above the plane. The groups which are present in horizontal line are above the plane, and the groups which are present in vertical line are below the plane. Okay. Now, who are below the plane? Is H and NH2 are below the plane. Okay. This H is below the plane. Plane already we have discussed. This is also below the plane. And CH3 and COOH are above the plane. Above the plane. Okay. And this carbon, wherever these two lines meet and there is one carbon, and that is you are finding 4 different groups, so it will be chiral. It is a chiral. So if you see priority of these groups, okay, you see priority. Let us see them. C star is attached to NH2. This chiral carbon is attached to COOH, C double bond OH. C star attached to hydrogen. C star attached to C. Okay. Directly attached atom, here atomic number 7, here atomic number 6, 1, 6. So NH2 will have high priority. Next priority, least priority is 1, least priority. And anyway, it is below the plane. So whatever you observe, you can write it. Whatever you observe, you can write. When you draw an arrow, what you observe, directly you can write. And among COOH and CH3, before also we have discussed that COOH will have high priority. So you will have second priority, third priority. We have to check the next atom. Here both are carbons, next atom is hydrogen, here next atom is oxygen. So COOH will have high priority. So on drawing an arrow, 1, 2, 3, 1, 2, 3, what you are finding? You are finding anti-clockwise. So anyway, least priority group is below the plane. So whatever you observe, you write. What did you observe? You observed anti-clockwise. So you observe yes. So you can write yes. Understood? Okay. Next, let us see. Here, wherever vertical line and horizontal line are meeting or crossing, there we have a carbon, and that is chiral carbon. Chiral carbon, right? So let me number it 1, 2, 3, 4. What is the name of this molecule? Tartaric acid. It is what? Tartaric acid. So second chiral carbon, let us see. At the second chiral carbon, I can go with priority number 1, OH directly. Here after C, you have 3 oxygens. Here after C, we have only 1 oxygen and 1 carbon. So priority number 2, priority number 3. This group, this below group, priority number 3. So rotate it. When you draw 1, 2, 3, when you draw an arrow, what you are finding? You are finding anti-clockwise, and H is on horizontal line. Horizontal line means above the plane. H is above the plane. So when it is above the plane, when least priority group is above the plane, whatever you observe, to that opposite we have to write. You are observing yes, so we have to write R. So at second carbon atom you have R. What about let us move to third carbon atom. Priority, when coming to priority, let us priority number 1, priority number 2, priority number 3. So rotate 1, 2, 3. you are finding R clockwise, but where is H? H is again above the plane. It should be below the plane. When it is below the plane, whatever you observe, you write. But when it is above the plane, whatever you observe, to that opposite you write. So what is here? Third chiral carbon. At the third carbon, you have S name or S configuration. Okay. Let us move to the next one. Here priorities. These two are chiral. This is chiral and this is also chiral. Okay. Priorities 1, 2. This is third priority 1, 2, 3. Okay. This is where, okay, above the plane. Least priority is what? Above the plane. When it is above the plane, what you observe, you have to write opposite to that. You are observing anti-clockwise, that is S. So what is opposite to that? R. So at I can mention 1, 2, 3. Okay, this is 4. At second carbon atom you have R. When coming to third carbon atom, let us see 1, 2, third priority again. Rotate it. When you rotate 1, 2, 3, what you are finding? Anti-clockwise. And H, where is H? H is again above the plane. When it is above the plane, whatever you observe, you have to write opposite to that. You are observing yes, so we have to write you are observing yes, so what you have to write? You have to write R. So most of the questions, if you see in previous JEE mains questions or NEET questions, most of the questions are asked based on this RS naming. Based on this RS naming, we can decide many things. We can decide a pair of molecules as enantiomers. We can decide a pair of molecules as diastereomers. So most of the questions in previous entrance examinations are based on this RS nomenclature. So you should be able to write RS nomenclature. Then only you can solve the problems. So if you can clearly follow this video, each and every point, then it will be very easy for you to write RS nomenclature, right? I hope so. You have followed it and you have known how to write RS nomenclature. Thanks for watching. Let us meet in the next video with a new topic, right?